Alright, how's everybody doing? The goal for you guys is for you to be able to multiply expressions with exponents. Alright, so first thing you want to remember, when you're multiplying the same numbers or variables together that contain exponents, simply add the exponents. Alright, that's all you have to do. When dividing, you subtract the exponents. Alright, and I'm going to show you why that is. Alright, so first, let's say I multiply 2 to the second power times 2 to the third power. Well, 2 to the second power is just 2 times 2. 2 to the third power is 2 times 2 times 2. And well, look, we're multiplying all of these together. 2 times 2 times 2 times 2 times 2 times 2. That's 5 2's. So that means the exact same thing as 2 to the fifth power. And if you look back, we're multiplying 2 plus 3 is 5. There's our 5. Alright, now when we're dividing, let's say I've got 2 to the fifth divided by 2 to the third. Alright, this is what that looks like. 2 to the fifth is 2 times 2 times 2 times 2 times 2. That's 5. And then 2 to the third, 2 times 2 times 2. 2 to the third. Alright, 3 2's. Now, whenever you have one number divided by itself, you get 1, right? Or they cancel out. So what we did is for every 2 that's on bottom, or depending on how many 2's are on top, will determine how many you cross out on bottom. I'm sorry, I'm trying to reword what I'm saying. You're not always going to have more numbers or variables on top than on bottom. Sometimes this might look the other way. But no matter what, when you cancel one out on top, you want to cancel one out on bottom. Or if you cancel one out on bottom, you have to cancel one out on top. So, I cancel out 2 on top and bottom, 2 on top and bottom, and another 2 on top and bottom until I'm left with nothing on either the top or the bottom. I've canceled out 3 2's on the bottom, 3 on the top. I'm only left with 2 on the top now. 2 times 2 is the same thing as 2 to the second power, or 2 squared. So if you look back, when dividing, just subtract the exponents. Look, 5 minus 3 is 2. Okay? So that's why that works. So let's try a couple of problems, alright, together first, before you try and work some out on your own. Alright, so for example, c to the fourth times c to the second, same variable, all you gotta do is add those exponents. It means the same thing as c to the sixth. Alright, next, negative 3y to the fifth times 2y to the negative third. Alright, well, hey, look, we've got a negative exponent, which means that whatever variable or number that's attached to, we're going to want to put a 1 on top, and that variable or that term on bottom. Alright, so, negative 3 times y to the fifth, I just turned into negative 3 times y to the fifth all over 1. Alright, and then 2 times y to the negative third, I turned into 2 over 1 times, and then y to the negative third, I turned into 1 over y to the third, because you never want to deal with negative exponents. Alright, now, when you multiply, this stays the same, and then these, 2 times 1 is 2, 1 times y to the third is y to the third. So this term right here became 2 over y to the third. So if it has a negative exponent, you just put that variable and that exponent underneath that number. Alright? Now moving on, because I don't have enough room. When you multiply these out, alright, the numerators, negative 3y to the fifth times 2, you get negative 6y to the fifth. Then when you multiply 1 and y to the third, you get y to the third. Now I'm going to show you why we get the answer we do. Negative 6 times y to the fifth means the same thing as negative 6 times 1, 2, 3, 4, 5 y's. And then y to the third is 3 y's. So for every y on top or bottom, I cancel out the other one. So y on top and bottom gone, y on top and bottom gone, y on top and bottom gone. So I've got nothing left on bottom, which is Nice, because now I don't have a denominator. Then on top, I just have negative 6 times y, which is the same thing as negative 6 y to the second power, or y squared. Alright, another example. This one's a little bit longer, but I skipped a couple steps. Alright, so if you're confused, you can always refer back to some of the steps we used to solve this problem. Okay, I've got 4 times c to the 4th times m to the negative 7th. That's all in parentheses. Times, in parentheses, 3 c to the negative 1, m to the 2nd. Close parentheses. Alright, now since this is m to the negative 7th, I know this is going to have to go underneath everything else. So m to the negative 7, I'm going to turn it into positive, but I'm going to put it underneath everything else. Alright, and then 3 times c to the negative 1 times m to the 2nd. Well, 3 and m to the 2nd are going to stay on top, but I got to turn that negative 1 into a positive 1 by putting that c on bottom to the first power. Now it's positive. Then all you have to do is multiply these out. Alright, 4c to the 4th times 3m to the 2nd. 4 times 3 is 12. c to the 4th times m to the 2nd. Well, you can't combine those because they're not like terms, not the same variable. So that's going to be it. And then on bottom, we've got c to the 1st times m to the 7th. Alright. Now I know the m came first here, but I rewrote it with the c first. That's just because I wanted to keep my variables in the same order that they are on top as they are on bottom. Cm, Cm. Alright, and now for the last part. When you're dividing, you're really just subtracting exponents. So I've got 4 c's on top here, 1 on bottom. That 1's going to be gone after I cancel it out. So that means I'm only going to have 3 c's left on top. And then I've only have 2 m's on top. I've got 7 on bottom. So those 2 are going to end up canceling out, leaving me with 5 m's on bottom. Alright? And again, we're dividing, so we're just subtracting exponents. 4 minus 1 is 3. And the higher number, that variable is always going to stay on top or bottom. Since the higher exponent's on top, that variable is going to stay on top. 7 minus 2 is 5. There's more m's on bottom though. So the fewer ones on top are going to cancel out. 7 minus 2 is 5. There's the 5. Okay? Now, I want you to give these three problems a shot. Alright, pause the video and I'll be back to work them out. Alright, so negative 5 h to the 6th times negative 3 h to the 2nd. Alright, well, negative 5 times negative 3 is positive 15. So we should have got positive 15. And then h to the 6th times h to the 2nd. I mean, you just got to add those up. That's going to be h to the 8th. And that's actually it. So all you had to do for number 4. Alright, multiply the numbers and then multiply the variables together. All that means you have to do is add those exponents up. Alright, now, next one, number 5. 4 times negative 2 is negative 8. Now I've got p to the negative 9th times p to the 6th. Now, I'm going to do something. We're multiplying these together, right? Which means we're going to add the exponents. Well, I can just add these exponents together like they're integers. Negative 9 plus 6. Well, guess what, guys? That's going to be negative 3. Or p to the negative 3. Alright, but you never want to leave your answer with a negative exponent. So we want to turn that into a positive exponent, which means we have to do this. That 8 will stay on top, but that p to the negative 3rd, we want to make it positive, which means we're going to put it underneath whatever else there is. So this will be p to the 3rd. And that's all you had to do. Alright. Number 6, last one. This one, and you know what, I'll work this out the same way. Because class, if you do what I just did here, where if you're multiplying right away, you got a negative and positive, you could put p to the 9th under the 4, and then that p to the 9th would be positive, and then you multiply out, then you divide, but that's just more steps. Okay, so this is a nice little trick. If you're multiplying these out, just, add the exponents. Negative 9 plus 6, well, that's negative 3. So I get p to the negative 3, and I want to turn that into a positive, so I got to put underneath whatever else is attached to that term. Okay? Next one, we can do the exact same thing. 3 times 7 is 21. So I get 21. Alright, I've got g to the negative 5th and g to the 9th. Well, if you add those up, negative 5 plus 9, that's going to be 4. So I've got g to the 4th. Then this side I've got w to the 3rd and w to the negative 6. Well, we're multiplying these. Really, you can't see any of the operations, class. So we're multiplying all this together. Every number, every variable. Alright, now the w's, w to the 3rd, w to the negative 6. Well, if you add those up, 3 plus negative 6 is negative 3. So now we get w to the negative 3rd. But again, just like in the last problem, you never want to leave an exponent as a negative. So we need to turn that into a positive. So 21 g to the 4th, that's going to stay. It's going to stay on top. And then on bottom we'll go w to the 3rd. Alright, and that's going to be it. Okay, now if, like in the previous problems, you want to show all your work, every single step, okay, do that. If that's what helps you solve the problems, do that. But what I just went through, those are nice, easy little tricks you can use to where, I mean, not only this year, but next year, the year after, when you start using larger numbers, you'll know these little tricks to where you won't have to do as much work. Alright? So, if you got any questions, ask me tomorrow, and I will see you guys soon.